Hello, welcome. Today let's try to solve another leet code problem, 560 Subarray Sum Equals K. So we are given an array nums, and for example, this nums equals to 1, 1, 1, and k equals to 2, and we are going to return the total number of subarrays whose sum equals to k. For example, this k equals to 2. Let me prepare as this example. Yeah. So we are going to find how many subarrays. So this subarrays means continuous non-empty subsequence of elements within an array. So this means for this 1 1 it's a subarray, and sum up of 1 1 equal to 2, and another is 1 1 is equal to 2. So we can find two subarrays. So we just need to return the number of subarrays which the sum of them are equal to the k. Yeah. Now let's try to solve this problem. If we use brute force, we have to check one by one. Maybe check, this one first, and 2 and 3. Yeah. And then we go from here. Yeah, we're gonna check one by one to check if the sum up of them equals to 2. Yeah. If we don't use prefix sum here, it's gonna be, so for example, for the first one, we're gonna use this one, and then here, and then from here to here. Yeah. And for the second one also, it will be cubic of n. If we use prefix sum, it will be n squared. Yeah. Yeah, but this also takes time because the value of n is 2 times 10 to the power of 4. Yeah, so this means we should use an algorithm less than O(n) squared. Yeah, this is why we can use a prefix sum with hash table to solve the problem. Yeah, let me explain a little bit about it. So for this nums, if we can make a prefix sum, so inside it will be 1, 2, 3. Yeah. So if we have a hash table, and in hash table we start the prefix sum. So for example, for the first prefix sum 1, we have a hash table, and how many of ones it is 1. Yeah. And then we're gonna check how many of 2's. So there's also 1, right? And how many of 3's? It is also 1. Yeah. Why we use this hash table? Because this hash table is used for calculating how many prefixes, how many subarrays which sum up equal to this k. Yeah. So, but while we are preparing this hash table, we are going to check. So for the first one, it is 1. Yeah. So for the second, when it goes to 2, yeah, we're gonna check if it is possible to make it equals to k. Yeah, because this 2 actually is our result. Yeah, because as you can see here, this 2, it means 1 plus 1 plus 1, it is 2. So this is a result. But up to here, we didn't get the result yet. But how can we get the result with this k, with k value 2? Yeah. So this means we have to prepare a 0, 1 inside the hash table to check. Yeah. So when it goes to 1 and 1, 1 minus 0, it is still 1. It's not equal to k. It is okay. But when it goes to 2, so 2, so 1, it is 2. We are going to use this 2 minus k. Yeah. So why use 2 minus k? Because when we are using this one, if 3 minus 2, 3 minus 2, it means our last value 1. Yeah, we just need to check if this value 1 is equal to k or not. Yeah, if this one equal to k, we're gonna count by 1. Yeah, so when it comes to 2, we're gonna use this prefix sum. It is 2. 2 minus this k, it is 0. Because this k is used for us to check. Yeah, basically we need to for example, we need to check two values, a plus b equal to k. Yeah. And while, so b is the prefix sum. So while this b should equal to b minus k should equal, let me make it, because we are going to calculate two values. We are going to calculate a value b as prefix sum, b minus a equals to k. Yeah, if b is here, a is here at this number 2, so b minus a means this one. Yeah, if this is equal to k, basically we are going to check the value of a. So a should be equal to b minus k. Yeah, so this is why while I'm checking this number, so this number as my so this number as b. So b is my prefix sum at this position. Yeah, at this position it is 2. So 2 minus k. K is 2. It is 0. If 0 is inside the hash table, so we're gonna count by 1. Yeah. Now when we count it by 1, and we also put this 2 and count it as 1 because 2 is not inside, so we count it as 1. And next we go to 3. Yeah. So 3 minus 2 minus this k, it is 1. 1 is inside the hash table and its value is 1. So we're gonna count it by 1. So 1 plus 1 is equal to 2, and 2 is our result. Yeah. Basically this is a DP problem, but as the tag called prefix sum, so we should learn it as a prefix sum problem, but this one we should also use a hash table to make it even faster. Yeah, so the time complexity will be O(n). Yeah. Now let me write the code. So we're gonna prepare some variables for the prefix sum, and I'm gonna prepare a result, and with a hash table b. And I'm also going to prepare the prefix sum. Yeah, I'm going to put it here. So the pre-sum result and d. The result should be started as a 0. The prefix sum also will be started as a 0, and d will be a hash table. So for here, I'm not going to put the pre-sum as a 1D array. I'm going to use the numbers directly because this can solve the problem. Yeah, this can save the memory a little bit. Now I'm going to loop through the nums. Yeah, and the pre-sum should be accumulated to this number. Yeah. Then this problem is also similar to two-sum if we are using a hash table, but it is also connected with the pre-sum. So I'm going to check this. I'm going to check if this pre-sum minus k, as I explained earlier, is inside the d or not. So if it is inside, my result would plus d with pre-sum minus k. So why use pre-sum minus k, not k minus pre-sum? I already make the deduction. Yeah, because basically for two numbers a and b, b minus a should equal to k. Yeah, so this is why we should use this pre-sum minus k. Yeah. So else, this is not else. Yeah, even it is not inside the d, we need to update the pre-sum. Yeah, if it is inside, we're gonna take the value. But as I explained earlier, so inside the hash table, it should be a 0, 1. Yeah, this is just for checking the conditions. So for example, yeah, I explained earlier. So for example, we are going to check k equals to 2, but inside there's a 1, 2, 3. Yeah, but for this 2, we need also to check it. Yeah, how should we check it? K, this 2 minus k, k equal to 2 equal to 0, so the 0 should also be checked. This is why we need to define a 0, 1 as k value pairs inside the hash table. Yeah. Now we need to update the hash table. So d with the pre-sum should equal to d dot get. Yeah, we need to get this pre-sum, but we are not sure if it is inside or not. Yeah, if it is not inside, it is 0, and then we need to plus a 1. If it is inside, it's also okay. We need to plus 1. Yeah. Now we need to return the final result. Yeah. Now let me run it to check if it works. I forget in. It should be for n in nums. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and passed all the testing cases. And the time complexity is just ON. And the space complexity is also ON because we use the actual memory as a hash table. But for the time, it is just one for loop. Yeah, inside we just used the hash table to get the values. And as you can see, this is a pretty good algorithm for pretty sum with hash table. Thank you for watching. See you